All right, so thank you everyone for coming to this Our Ladies Philly meetup. Okay. So Our Ladies is a worldwide organization that promotes gender diversity in the R community via meetups and mentorship in a friendly and safe environment. Gender diversity includes, but is not limited to cis, trans women, trans men, non-binary, genderqueer, and agender. Uh, During the course of this meeting, the Our Ladies Code of Conduct applies, and you can read more about that at ourladies.org/COC. And you can report any events to reporting at ourladies.org. There's different ways that you can get involved in Our Ladies. We do have a website, ourladiesphilly.org. You can learn about our future meetups on the meetups page. You can join our Slack community by emailing us at phillies@ourladies.org and we'll add you. You can watch these meetups on our YouTube channel, and we would love to have you volunteer as a speaker or a mentor or an organizer. And you can do that at that link, ourladiesphilly.shinyapps.io/mentorship. Or you can also reach out to myself, Shannon Pelleggi, as a co-organizer of Our Ladies Philly, or Jenny Long as also a co-organizer of Our Ladies Philly. So we are so delighted to have Irena Papst today. And I believe this is your first speaking occasion for Our Ladies.
Yep.
All right, this is amazing. And I will let you introduce yourself and tell a group about yourself.
Sure. So my name's Irena. I am a scientist at the National Microbiology Lab in the Public Health Agency of Canada. I mostly work on modeling the spread of infectious diseases using dynamical mathematical models. I have been very lucky. Was lucky when I was in even my undergraduate to be exposed to R and other open source tools in the research groups that I was working with. And since then, I've always been really interested in open source software and developing it, and also making my research very reproducible and just trying to be efficient and good at what I do and how I do it. So currently, I put in there my current favorite packages and are targets, renv, and config. And I'll mention all of them during the talk. So I'm guessing now I should show my slides.
Feel
So,
free to take the screen away.
sure.
And if you have questions during this talk, I will be monitoring the chat. And actually, I didn't get the link for your slides yet. If you can drop that in the chat
Yes,
real quick.
that is now in the chat.
Okay.
So
So questions can come in through the chat and I will flag them, or I will save them towards the end, depending on the nature of the question.
great. So everyone can see my screen, I'm hoping, or rather can see the slides on my screen.
You're good. Yep.
Okay, perfect. So today, what I'd like to spend a little bit of time talking to you about is how you can sort of manage your various analyses that you're coding in R using a really cool R package called targets. So I don't know if this happens to any of you either at work or at school or whatever phase of life you're in. But someone might come to you and ask you, "Hey, can you combine these data sets for a team or for yourself?" Maybe you find a few data sets online that you'd like to kind of pull into one entity to work on. Or perhaps you need to make plots for a Tuesday morning slide deck that your boss is putting together. Maybe you're working on a manuscript and you want to put together some tables and figures for your work, or this is probably only going to apply to me in this group. You might be forecasting a disease over the next few weeks. And so, what do these tasks have in common? I think what's important here is that other than tasks that you can do in R, they're of moderate complexity. So, what I mean by that is there are several inputs that need to be put together that are coming together to be used in your analysis. And perhaps there are several outputs that you'd like to produce. And the other key is that I might need to repeat or reproduce this task or these outputs. It might be a recurring task, or perhaps because I care about reproducible research, I want to make sure that I'm accountable for my results and I can reproduce them if I come back in a few months without too much difficulty. So let's focus in on, I'm just going to focus on the application that comes from my work, which is about forecasting a disease. And I've been asked versions of this question over the last few years. Can I forecast a disease over the next few weeks? And if you were to tackle this, you might think, okay, let's start with a simple script. Let's load some libraries and read some data in, simulate it with some functions I've written, including, let's say, make forecast, and then let's plot the results. And this simple script might be just fine for what you need to do. And I'll just say here that the point of this talk will not be to convince you to always use a tool like Targets. I just want to motivate you to perhaps add it to your toolkit because it can be really powerful in tasks of moderate complexity. So I do this, I submit my plots to my boss or my team, and I get sort of this response often, which is, this looks great, but what if, I don't know, what if schools reopen and that increases spread? Or what if there's a new variant on the scene, as we saw during the SARS-CoV-2 pandemic? In that case, there can be a lot of uncertainty when forecasting. And so what we try to do to manage that uncertainty is to consider discrete scenarios. And so perhaps I take my script and I make it a little bit more complicated. Now I have a scenario argument for my make forecast function. And in it, I'm just going to iterate over 3 distinct scenarios I've coded somewhere else. Okay, that's a little better. At least now I'm looking at different things and I'm answering the question of interest. But maybe each scenario actually takes like 90 minutes to run. These simulations can be really intensive. And this is not unique to my use case. I think there's a lot of data science tasks that and science tasks that can just take a lot of computing time. So perhaps I will parallelize, right? That's a common solution. So I might, write a couple lines to include a parallelization library and make a cluster and register my parallel workers, etc. And then just iterate over these scenarios in parallel. So instead of taking 90 times 3, however many minutes that is, it just takes 90, let's say, if I have enough workers. Okay. So what I would do to run this analysis is maybe that script that I just showed you, let's call it forecast.r, I would just run it. And what's good about this, and what's good about scripts in general, is that they're reproducible, right? If you, in theory, if you take a script and you start it in a fresh R session and you source it from top to bottom, it should produce the same results with an asterisk. But the problem is that that's not often how we work. We usually use scripts as a notepad and kind of work with them interactively, for better or worse. And that can break reproducibility. Like I can maybe perhaps if I go back, if I'm not careful, I can, play around with sourcing different parts of this script. I might update my data. I'll have to rerun this line here, and then I'll have to rerun my analysis again, right? I would call that interactive use of a script. And that can be a problem if, for instance, I don't know that, or maybe my parameters change for one scenario and they only change for one scenario. Why am I running all 3 scenarios again? If I'm sourcing my script from top to bottom, I'm going to run through each one again. And 2 of those scenarios are up to date. Like there's nothing that's changed with them. Perhaps I'm actually getting an error in the last scenario. If I'm sourcing my script from top to bottom, I will have to run through scenarios A and B before I get to the one that's bugged, and that will take time. Or, which is more likely, very likely for me at least, I should say, I might be working and I step away for a meeting and I forget which results are up to date. And so, of course, there are ways to get around these issues while working still within a script framework. I mean, I could, rewrite my script a little bit to just run one scenario, or I can check the date modified on my output files in Finder or Window Explorer to see like when the last time that file was generated. But the point I want to make is that that's a lot to manage. There's a lot of management going on and not a lot of analysis going on. And so the problem, I think, and this is how I'm trying to distill it, is that the code I use to run my analysis is mixed up with the code I use to manage the running of my analysis. And I call that kind of management code. So I'll give you a really simple example. It's a bit of a meta point, so it might not be super clear at first, but I hope through the talk it will get clearer. Here I have a very simple line of code. I'm taking my data, I'm putting it through this make forecast function that's going to do something presumably useful, and I'm assigning it to an object called sim. So if I break this down a little bit, I would say that line 3 is actually the analysis code. That's what I'm paid to do. Like that's where what my brain is supposed to be working on. And assigning it to an intermediate object, potentially writing that object to disk, that's management code. And, that's a simple example, but other management code could be that for loop that I wrote, right? Iterating over the scenarios with a for loop versus a parallel for loop versus lapply, lots of other options. It could be saving that object to disk or an RDS file, right? So the problem is that's all kind of jumbled up in my script, and I can't differentiate between the two and make my life a little bit easier. So the solution, I think, is to, first of all, delineate between those two things, and then outsource the management side of things to a pipelining tool like targets. So now that I've introduced the word pipeline, I have to explain what I mean by a pipeline. So there are formal definitions for this, but I think for the purposes of the talk, what I want to define it as is a pipeline is a layer on top of your analysis code that actually encodes the recipe for the sequence of generated objects in your analysis. We can also call those targets. And it's not just a recipe for each of those individual objects or targets, but also how those targets depend on each other. So I'll give you a picture because I think a picture here is worth 1,000 words. So of course I have, code to produce sim and plot, that's elsewhere. But the pipeline layer of it is the fact that I need data to make sim, and then I need sim to make plot. And that interdependence is somehow encoded in a way that pipelining software can understand. Pipelining software like targets, and it'll help you. Targets will allow you to write, manage, and execute pipelines. Okay, so that's kind of the preamble. Let's try to take a look more concretely at what this means. So I have my script that I wrote before. Let's just focus on one step, the simulate step. Before, I might have just written that one line where I'm assigning the output of make forecast to sim. If I'm working in targets, it's a bit more verbose, but I promise you there's a payoff. So instead of assigning to a local variable called sim, I'm going to use this scaffolding. It's called like the function target acts as scaffolding that basically puts together a target with a given name that I'm going to name. So let's say sim, and a recipe for that target, which is kind of packed into this one function. It's not that much different from what we were doing before, but it unlocks a lot more down the line. Now, you can't just define targets anywhere. It's not just like you open a script up and you start defining targets and things will work. You have to kind of play by the rules for targets to work. So you define them in something called a R targets file, or rather, targets.r file. This is your pipeline file. And targets makes it really easy to set this up by giving you a utility function. If you're familiar with the use this package, it's kind of a similar paradigm where you just start a session, you load the library. This isn't an interactive session. You use targets, and it's going to make a bunch of useful files in your project that you can then go in and edit to write your pipeline. So let's take our script and now turn it into a pipeline. So the way that these pipeline files work is you do have to load the library targets so that you can kind of call these functions that it uses down the line. And then you will source any helper functions that you need that maybe you've written for your analyses. So in here, I have a file for the make forecast function. I have a file for plot forecast. And then here's where it's a bit different. So normally when you're starting a script, you might load your packages right away in the script. The way that targets functions is it's actually not going to run your analyses in your current interactive R session where you're deploying the pipeline. If you're just in an R console, it's not actually running the analysis in there. What it's doing is it's calling a separate subprocess of R using the caller package. And so it's starting, and then it will run your analyses in that separate subprocess. And the reason is because it's isolating whatever you were doing interactively from the actual running of the pipeline. And when you do that, you have to tell it ahead of time what are the packages that you're going to need to call in that external session. And that's how we do it here with this syntax. Okay. Once we've done that, the pipeline is simply just a list of targets. So we have a list flanking everything here, and then we will not click that. Sorry, I just messed up my speaker view. Just give me a second. Uh, sorry about that. Okay, so I realize there, I think we are where we were. So I have my list. I am going through, there we go. So I have my list. I have my different targets in there. And all I'm doing is essentially, my script was really simple. I was just assigning, the output of a function to a different name. So this is more verbose. Like it does, you can see there's kind of all sorts of stuff around there, but it unlocks a lot of power. So let's see what that power is. So first of all, it's really easy to make things. When I have a script, if I just have one script, I know I source that script and I get stuff out. I don't necessarily know what I'll get out right away if I'm just new to the project. Or if I have multiple scripts that interact with each other, I may not know what order to run things to get the thing I want. The way that the pipeline or targets works is that it allows you to make things really easily. So remember I had a target called plot. I just call in an interactive session tar make plot, and what's going to happen is targets will launch that subprocess of R, load all the packages I need for my pipeline, and make the plot object. So please ignore this text here, which I thought I had gotten rid of. What it's doing is it says, okay, to make plot, if you'll remember, right, I had plot which created sim, which created, or sorry, data which created sim, which created plot. So it's going to first make the data, whatever it needs to do to make the data. It'll tell me also how long it takes. It's then going to make the simulation target, the simulation object from data, and then finally it'll make plot. So I don't have to remember, okay, you have to first make the data, then make the simulation, then make the plot. I just ask targets, just make the plot for me. I don't have to know that. So that's one way to outsource that management of the code. And then it's really easy to read things when you want to look at them. So instead of, sourcing the script and a plot will pop up in my RStudio window, I'm just going to tell it, okay, you've made the plot, now read it for me, and it'll show it to me. And it's not the case that I would have had to make the plot right now to see it. I can load it from the last time I made it, and I don't have to worry whether that's done or not. It'll tell me. Another thing you can do too is when you read, there's a slight distinction. You can read is like printing, and then loading is like creating an object in your current session with that same name that stores that object. So there's a slight difference there, but it's also really easy to visualize the overall process. So sorry, I've suppressed the command here, unfortunately, but there's a command called tar viz network. And what that'll do is it'll take your current pipeline and it'll show you what are all the objects. So that's the round stuff. The triangles are the functions that create those objects or that are involved in the creation of those objects. And it shows you kind of how those things depend on each other. And you can kind of move around and play around with this interactive visualization. What's really nice about this, I think, is that you're not only tracking the different objects that create, like, it's not just data that creates sim. This make forecast function also creates it. And so if something happens, if something changes with that function, you want your sim to be updated potentially, right? So let's take a look at that in more depth. Targets will only make what you need. So if I, for instance, update my plotting function, suppose that initially it was just plotting the way you saw it, and now I want to make my points red. I want targets to remember, to realize for me that that means that if I've updated my plotting function, my plots need to get updated as well. And you can see from this graph in the background, I have a pipeline running, or I ran a pipeline in compiling these slides. At this point, my plot forecast function is outdated. So everything else is up to date. So it's not going to do, it's going to skip a bunch of stuff when I ask it to make everything, which is what happens when you just invoke tar make. It'll just make whatever's there. But it's going to say, hey, actually, plot needs to be remade because plot forecast changed. So it's going to do that and it's going to come back to me. So instead of like with a script where it would just rerun everything from top to bottom, it's only going to make what you need. And it's going to keep track of what it needs to make. I don't have to think about it. And then when I rerun it, of course, I can check the network again and I can see that, yeah, actually everything is now up to date, as you can see from the legend. Fantastic. Now, this is a really simple example, but in your daily life, at work or at school or whatever, you might need more, your scripts might look more complicated. And indeed, the script that I showed you at the beginning was, I needed to parallelize it because it was just too, it's a task that took too long and I have computing power to spare. The thing with targets is that it's very easy to scale up your pipelines. So you can do distributed computing with a companion package called Crew. So what that would mean is all you would do, it's really easy, which is nice, is you don't actually fundamentally change your code. In the script, I had to change my for loop to a parallel for loop. Here, all I'm going to do is I'm going to change the way in which my pipeline runs. So there are some options that you can set at the start of your pipeline script, one of which is to specify a controller for distributed computing. If I just am working locally on my computer and I just want to do 2 workers instead of 1, this is how I would do it. And the point is that I'm still running the pipeline in the same way. My pipeline looks the same. I haven't contaminated my analysis code with more management code, right? All I'm changing is how I'm running it. And this is really powerful when, especially if you are in a situation where you have 2 different, maybe you have a development environment, it's your laptop, and then sometimes you deploy your code to a server because you need more computing performance. If you have all that parallelization stuff intermingled with your analysis code, it can be really hard to go back and say, hey, I have to add one more thing, and I want to make sure it still runs on my computer, and then it'll run on the server. And, having to go back and forth is really hard. But if all you do is change the controller that you're using, depending on where you're working, it can make things a lot faster for you and more robust. So, another thing about scaling that's important is, or rather, another feature to help you scale easily is branching. So there's one thing to, take code that is written to be branched, like, with some kind of for loop, or sorry, it's written to be parallelized. But it's another thing to actually think about repeating different parts of your analysis in a smart way. So, branching is a feature. There's 2 types of branching, which I won't get into right now, but you can think of it as taking parts of your pipeline and repeating them. So I'll give you a really kind of quick example, but the setup is basically let's say you have 2 targets. You have some kind of parameters for an experiment, and then you have a function to run your experiment. The only difference so what I could do certainly is I could have my experiment function actually handle multiple parameter sets within, maybe with a for loop, and then just give me one thing out. But the point of targets is to not taint your code, right? So just write the experiment as you'd want to run it once, and then handle running it multiple times outside of the actual analysis code. So all I need to do is tell it, okay, run this, make the parameters, sample 10 of them, let's say, and, run my experiment on those parameters, but actually map this target, or rather repeat this target across the different parameter sets. So it doesn't look like much of a change, but what's really nice is there's a lot going on under the hood so that now I can say, you know what? I want to take my results and I want to visualize them just all on one plot. Maybe there's some faceting going on, one panel per um, result set. Okay. But maybe can I also just see one plot per um, parameter set? Like maybe for some reason I need that. It's really easy to just say, okay, in the first case, I'm just going to take these results, which internally are actually represented as a list of results, but just, visualize it. Don't let me worry about the details. Or I can tell it, actually, no, iterate over that list and give me a list of plots out. So there are small minor adjustments that you can make to not repeat yourself and also get very flexible representations of your outputs so that you can make the plots or the outputs that you need. Okay. So this is not a fantastic example because I haven't actually run it to show you, but there's a really nice walkthrough in the targets user manual that will help you disentangle branching and understand the use cases that I just don't really have time to get to that depth. Okay, so I think I will say before I move on that I do think branching is one of the most powerful features of targets. I use it almost every time I set up a pipeline. If you're doing a lot of statistical work, you might be performing replicates of some experiment. I often use it because I'm forecasting across multiple provinces of Canada. And so I want to basically run the same thing, but with different inputs across different provinces. And it allows me to not repeat myself, basically. And the other bonus here is that because I've played, by targets as rules, I can then let it figure out how to parallelize this without me having to worry that, oh, actually, I want to parallelize, let's say, one worker per province. That may not actually be the most efficient parallelization because there's other stuff going on in my pipeline. And so I can just say, targets, just run this with like 4 workers. You figure out how to deploy the tasks across those workers. And that's going to be probably much faster than anything I can do. Okay. So one caveat is that this talk is not a targets tutorial. I've tried to give you a bit of a flavor of how it's used and what the main characters are in its use. But there are a lot of nice tutorials online. And as with kind of any software, it's better to just kind of jump in yourself rather than listen to someone talk about it. So I'll just point to this here. And again, the slides have been linked in the chat, so you can go to them and click these links yourself. But there's a really nice 4-minute walkthrough in the user manual of targets. It's one of the packages that has the best documentation I've seen in an open source setting. So if you need help with it, it's often, I find often the case that I am able to answer my own questions fairly easily. So watching that walkthrough will kind of get you going. I think the stuff that I've presented so far is basically kind of the walkthrough. So not a bad idea to reinforce that if that wasn't all clear. There is a more in-depth tutorial online as well that's meant for like you sit down for a couple hours and work through some things. There is actually a course in the Carpentries Incubator. I don't know if everyone here is familiar with software carpentries, but they're very useful, kind of self-guided or sometimes like live run courses for different software tools. There's one course that's in progress. Things are kind of rough, but I looked through the materials and they looked quite useful already. So that's also worth checking out. I do think the best way to start though is to actually take a script that you have or a set of scripts that work and try to convert them into a pipeline. And if you're going to do that, it's really useful to use the targets manual to kind of work through it and figure out the pieces that you need for the work that you need to do. So I said this wasn't a targets tutorial, that there are tutorials. So what is the point of this talk? So the value I'd like to add today for you is to give you a bit of an introduction if you haven't heard about targets, but also to help you think about targets and pipelining. And I think most importantly, to learn from my mistakes as someone who's completely self-taught in this. So I'd like to spend a bit of time now just giving you some tips for pipelining in general, but specifically with targets, and also just how your workflow is with this tool. So we'll start with some design tips. Um, a picture really is worth 1,000 words sometimes. I find it easy to, when I'm sitting down to try to write down an analysis, it might be kind of clear in my head, but then I start coding and I go, oh, wait, I forgot about this or I forgot about that. So just having a sketch ahead of time to make sure you've ironed out the major steps, I think is really useful. And I think
Exactly.
a really
Yeah.
important thing would be to start small and then iterate and make your pipeline bigger and bigger. I mean, Targets is built to encourage you to do that, right? By allowing you to do things like branching and distributed computing after you've already written a basic pipeline. So you don't have to have the big picture in mind immediately. And so, if your project kind of evolves, the tool can still keep up with you. But sometimes it's good to rein yourself in and just really focus on the basic pieces and then build on top of them. The other thing that's really important, and this is a kind of an art, is to right size your targets. So it's a bit of jargon, but what I'm basically just mean is that you don't want targets that are too small or too big for the task. So when I say small or big, I mean in terms of how much each target does, like the amount of code that it goes through and computations that it does. So there's a trade-off. Larger targets, what's nice about them is that if they get skipped, you can get bigger speed ups. So if you put a bunch of stuff into one target that takes a while, if that gets skipped, like for instance, maybe that's your simulation step. If you've run your simulation and everything else is up to date, then you can do all the downstream visualization and reporting without having to rerun that. And that's a big boost when you're developing those things. But smaller targets give you a bit more control over what's skipped and what isn't, and also give you control over looking at intermediate results. So perhaps there's something in my simulation. I've been in a situation before where I put together a really big simulation target and I realized actually there's an intermediate data frame in there that I need to get into to make a diagnostic, to take a look at if my simulation was successful. And then I have to break up that target. So in that case, it's not just about what's getting skipped, it's about what I can actually get my hands on to look at and make downstream objects with. It's not easy to figure out how to size your targets, but something I wish I could tell myself when I first started is that not every object that I'm making in my session has to be a target. That's kind of the temptation when you start. But I think it's important to think about a few things. One is, will I want to update the contents of this target? I know I've been burned by hard coding before, but sometimes it's okay to hard code things. Like in the sense that if this is, if I know I'm always going to want to compute a 95% confidence interval on my results, it's okay to code that 95% in. It doesn't need to be its own target, because every time you make a target, especially kind of near the top of your pipeline, your inputs, that's another knob. Not everything needs to be a knob. So another thing is to think about is also, will this target get updated independently of other targets? Is this something that, I actually really want bundled with other things, or do I want more control over whether it's going to change? Right? So one example might be, I have a series of files that get input into my session for analysis. I can do that kind of in one go by just, listing all the files and having a target that reads all those files in a row. But maybe there's one file that always changes. And if that file changes, that means I have to reread all of those files. Maybe that's a slow process. So maybe I want to separate out that one frequently changing file and then leave the rest of the that the other files in their own big target, so that when that one frequently file changes, I don't have to rerun the read of everything else. Another thing to think about is, am I saving an intermediate object as a target that I'm never really looking at? Or is this something that I actually do want to get my hands on? So if it's something that I don't really need to look at, just stick it within a bigger process where it belongs and don't worry about it. Okay. Another important thing is to be really thoughtful and systematic with your target names. I mean, you don't have to, but it will help you. So targets actually supports tidy select syntax. So when you're naming your targets, those are names that you're going to refer to when, let's say, you're reading targets or making them, etc. So if you're familiar with tidy select syntax, right, this is syntax that you might use in dplyr. Like you can specify, objects or columns in the case of dplyr that start with or match some regular expression, etc. So you can use that kind of meta programming layer with targets as well. So if, for instance, I have, I want to think about how I'm going to use them, how I'm going to interact with them. So I might have a couple targets that create plots. And one convention that I've found really useful is to usually start my plotting targets with plot, because then when I make them, I can use this tidy select syntax of starts with plot, and it will just make those. Now, it may not be the case that I always want to only make plots. It may be that maybe I delineate, my pipelines get more complicated, and there's kind of one phase that I, want to run together, and there's another phase that I want to run together. I could start or end the names of those with some other keyword that's going to help me isolate them from the other targets. So think about the usage, and don't be afraid to go back and rename your targets if it's starting not to really make sense with how you're working, if you're kind of bending over backwards to pick out the ones that you need. The other thing that's really important is so it's important to be explicit about your dependencies, because the whole name of the game with using targets is to be very clear and to delineate this thing depends on that thing. And it can be kind of, you might not realize there are dependencies where there are in the beginning. So initially when I wrote that pipeline at the beginning, you may not have picked up on this if you've never used targets, but what I did was I said, I'm going to create a target called data that involves reading data from what is a file path, right? I've actually accidentally baked in a dependency here. So targets, just by writing it this way, doesn't know that, hey, this is an external file and I need you to watch it for changes. All it sees is this is a file path and it's baked into the target and I'm going to read it, and that's fine. So what you want to do is you actually want to say, hey, this is a file, it's its own target. You need to watch this separately. So this target will watch the file, and then this one will do the reading that you need to do. So this is a common task, which is, loading in files into an R session. So there's another companion package called tarchetypes that basically takes these frequent use cases like loading files or looking at data from a URL or creating a Quarto doc. And it basically just gives you a wrapper for the targets that would need to be made to do this kind of task. So you can, of course, do things manually with targets just by itself, or if you're willing to bring in another dependency, you can use tarchetypes to read a file specifically, let's say. Okay. Another really big thing, and this is very kind of, this is one way to use R, but it's a very common way to use R, and it's a very useful way. And targets buys into this paradigm, which is that you should be using functions. So when you have things that you want to do, common tasks, it's better to write a function that encodes that task and reuse, like keep calling that function when you need it, than to be like copy pasting code and making slight changes, right? And there's 4 advantages. So one is it makes your code more readable, because ideally, if you use function names that are descriptive. Um, if something changes about how you want to do that task, you only have to change it in one place in the function definition, and then that will cascade down to every time you call that function. It also means that you will not make, well, you shouldn't be making copy paste errors because you're not copy pasting. And it means it'll make it easier kind of on a larger scale to reuse bits of code that you find yourself using often. So um, I will say that when you write your targets, whatever goes in here, the recipe for the targets, doesn't have to be a function. All the examples I've shown you include functions because I really think that's the way to do it. But you can put arbitrary bits of R code in here between curly braces like a script and it will run. Things will run. But I don't think that's good practice. So instead, I would urge you to use functions. Okay, so that's from a design perspective when you're sitting down to design your pipeline or when you are actually designing it and building it. There are a few tips for workflow that I think are also really important. So what I mean by that is when you're sitting down and you're actually using targets, don't be afraid to crash the pipeline. So I know certainly when I started coding, I was always afraid of errors when I was writing scripts or just working interactively, and I learned to embrace them. Similarly, when you're faced with a new tool, it gets, I find, scary again to make the tool crash. So just don't worry if you get errors. It's just a learning opportunity. So um, suppose that I'm making my simulations and okay, my data target's up to date. Fantastic. Don't have to do it again. I'm going to start the simulation. Okay, I have an error. This is kind of what the target's output will look like. So it's actually very helpful because it will tell you, you can retrieve the error messages in more depth with this command. You can look at the debugging guide here, which I would highly encourage you to read because that's a very useful section. And you can ask for help this way, but it tells you what the error is. So there are a couple of ways of getting in. The problem is that this, as I mentioned before, this is not actually running in your interactive session. The stuff that this invokes, it's not like somewhere in your local session you can look at the variables and see, okay, X wasn't found, etc. It's calling another R process. And to get into that R process takes a little bit of work. It's doing it for a good reason, which is reproducibility, but it can create a barrier. What I used to do, and I'm not ashamed to admit this, is I'd be like, okay, there's a problem in my make forecast function. I'm going to source that file. I'm going to debug it so now I can get into there. I'm going to load the stuff I need from the pipeline to run this function, and then I'm going to run the function. Now it's in my interactive session, and I'm not dealing with this sub-process. There's a couple of problems with this. Here, it's not that bad, but if my function depends on like 7 targets, I have to load them all. And that's a drag, and I don't want to do that. The other problem is that and this is going to be a problem too with what I'm suggesting down the line. I can't entirely be sure that what I've loaded is actually what's being run in the pipeline, like what's actually been called in the pipeline. So there's a couple of strategies that are covered in that debugging chapter I mentioned, but one that I really like that must be newer because I didn't come across it before is you can actually, in your targets file, the pipeline file, you can set an option to save the workspace of the pipeline when there's an error. And so what that's going to do is, again, this is running in a separate process. It's creating a bunch of, R objects in there, and then it's crashing. And in theory, once that process shuts down, all of that is gone, just like when you close your R session and you don't save your workspace. So this is going to save your workspace. And then when I go into my interactive session, starting from here, I can say, okay, so presumably what happened is before I start here, I've now, done the thing on the previous slide, which is run the pipeline and hit an error. And what I can do since I had this option enabled is just say, hey, load the workspace for this target. Like what that does is it'll load any function definitions that I need for the pipeline, any dependencies, the stuff that gets input, and load it as it was when you crashed, basically on error. And then I can do the thing I want to do, which is debug that function, which I know is the problem, or I can insert a browser statement at the top of that function For whatever reason, I prefer doing that. And then run this in my interactive session, and data is going to be there. Make forecast is definitely there. I'm debugging it and just kind of figure out what's going on. Another thing you can do that's helpful is you can actually get the error traceback of that target similarly when you have this option set. So that'll kind of just put out like, okay, I was doing this, and before that I was doing that, and before that I was doing that. And it'll give you kind of the stack of function calls that was executing when the error triggered. Okay, so unfortunately, errors are going to happen. Thankfully, there are ways of kind of getting behind that wall in targets and figuring out what's going on. This is a big one for me. And this is true in projects in general, and this is more of a project organization point. Not every idea you have for an analysis needs to immediately go in your pipeline. So I like to keep two scratch folders. I'm not entirely sure that this is a good idea the way that I'm suggesting it, but this is what I do. I have one that I call dev, which I think of as like code development, like package development almost sometimes, because I am sometimes developing packages. And that's where I keep my .r files that are kind of like in progress, or here are some ideas, here are some function definitions. I don't want to commit to adding them to my main code base yet. I'm just kind of working on them and figuring things out. And then I have another folder called notes where I keep more of that literate programming stuff where like if I have like an RMD or a Quarto, QMD is probably more timely now. Some kind of document where I've woven in text and code because I'm still thinking through, chewing through a problem, often talking to myself in this notebook and like weaving in code. That's where I would keep it. And to me, these are folders that I know like this is all transient. I don't keep anything here that's important to me, kind of in the long term. And this may not work. Like, it's not, there's no guarantees. This is just my kind of play space. And so when I have an idea, I, create one of these two files in one of these two folders and play with it. And then I I can use I can still use targets when I'm doing this. Like I can use load and read at the top of these scripts or in these notebooks to kind of pull in objects that maybe later on when I implement this analysis in my pipeline will be formal dependencies. But for now, I just need stuff to play with. And then I only put it in my pipeline if it's really a keeper. Like if this is something that I will maybe want to reproduce regularly, or I want to enshrine for some reason in the memory of this project. Another really big thing, and this is not exclusive to pipelines, but pipelines especially can grow unwieldy. They can get really big. Analyses in general can get really big. And it's really important to take a step back when you're considering adding something new and ask yourself, is this in scope of this pipeline? Is this what I built this pipeline for? So scoping is really big, especially if you talk to people in like software development or people who do develop packages, whether there are or not. It's really good to know what you're trying to do, because when people start using your tools, you're going to get all sorts of requests and like, hey, I wish I could do this, or I wish I could do that. And you have to decide, do I want to add this to my code base and have to maintain it and make sure it's working all the time? Or am I going to leave that to someone else or another project? Like being very clear about the goals of what you're doing with your pipeline or your project will only help you, I think. So what I do is I want to keep my code focused. It's really simple. I try to write a statement that in 1 or 2 sentences describes what the goal is of my project. I use a README file, just a readme.md file. This is an example from my website repository. It doesn't have to be complicated. All I keep in here are files that generate my personal website. I don't keep other stuff in here, like the files that make my CV that is on my website, right? I don't keep, other, I don't know, detritus that like isn't actually going to make my website. And that makes my life a lot easier because I know where to find stuff when I need it. Like I know my website files are just here. They're not scattered necessarily. And if things are across different projects, I make notes of it in these READMEs. So when you're writing your pipelines, start off by, saying, okay, this is what I want this pipeline to do. You might have to revisit that. It might evolve over time, but try to maintain your clear focus by writing it down. And when something is out of scope, don't be afraid to make a new project, a new folder, a new pipeline. I often have, especially in the work that I do, the paradigm I often end up with is I have one repository that actually runs my analysis, does a simulation, does a forecast, and another repository that does the reporting based on the outputs of that. So maybe makes a Quarto document, maybe makes a couple plots, makes some PowerPoint slides, etc. And by kind of keeping those things separate, it can, of course, introduce complexity in maintaining those pipelines. Um, but it does help me make sure that things don't get out of hand in one project. Okay. So final thoughts. There is always going to be this fundamental tension between reproducibility and interactivity. So you may want, you know, best laid plans, your analyses are always like, I can sit down and go back 2 years and just reproduce those figures that I made for some paper, right? That's what I want. But when I'm working on that paper or that project, I need to interact with the code, right? And when I interact with the code, I break that reproducibility. So both have their place and both are important, but it can be really hard to move between the two without, shooting yourself in the foot when you want to go back. And to me, targets above all kind of makes that move, that kind of shifting between reproducibility and interactivity, much easier for analysis projects. The trade-off is you have to learn to speak targets. You have to learn how to use a new package, and there is a time investment. I don't know that it's necessarily worth it for everyone, depending on the kind of work that they do. But I hope I've at least made you a little bit curious about it. And if any parts of what I've talked about have resonated with you in terms of, oh, that might make my life easier, I think it's worth spending half a day learning about this package, like in a hands-on way. I got this question from Shannon when I was asked to give this talk. So I'll quickly go over my thoughts about this. So should every project be a targets pipeline? I think this is a great question because I definitely went through a phase where I thought everything needs to be a pipeline. This is the best thing I've ever discovered. I'm going to use this everywhere. And I don't think that's necessarily true, as with, there's always a gray area. So there's a couple of things that I would suggest that you think about. The answer is no. The first thing is maintainability. How maintainable do I need this project to be? Do I need to be able to go back to it? Is this something quick and dirty that I'm going to sit down and just write a quick script and make a plot and send it off to a collaborator to look at? Or am I going to have to come back to it tomorrow or in a few weeks or in a few months and do that again? And then have to pay the price of remembering how to do it or documenting how to do it. Will I need to pass this off to someone else? Now, this one is a bit tricky because it requires your team or whoever you're working with to buy into the targets paradigm. Like you can't, like I've tried this and it works moderately well because the using a targets pipeline is actually not that complicated. Developing one is more complicated. So when I've been in cases where I've like had a project that needs to run when I'm on vacation, I've, managed to kind of get someone set up and explain how to use a pipeline in like an hour. But if this is a situation where I'm collaborating with someone on the analysis and I need them to come in and add stuff to the pipeline, then it's a bigger ask. But I think the overall gain for a project that's getting passed around can be really big if everyone buys into the pipeline paradigm. Another thing to consider is modularity. So am I going to be, if I'm thinking about the analysis that I'm about to write, am I going to be in a situation where there are very obvious places to make my code modular in some meaningful way? So for me, if I'm running a forecast for, 6 provinces, that's very clearly like I'm going to need to be modular about how I write my code, or I'm going to write 6 scripts that all look basically the same, right? Will I be performing replicates of an experiment? So maybe it's a case where I'm writing code to create a forecast ensemble, like where I'm like varying things between like to represent the uncertainty and let's say the parameters of my scenario. I might be running a simulation over and over and over again with slightly different inputs to get a sense of the uncertainty around the outputs. And in that case, again, this is a kind of a modular operation, and that's where Targets has tools like branching to help you. And the last thing to consider, I think, is complexity. So will my analysis have many different interdependent bits? Like, are there things that kind of depend on each other? And the graph that I will eventually draw will be kind of complicated. Or, will I have to remember if I want a plot, do I need to remember to run this and this and this? Like, once that input list gets kind of complex for me to remember, that's a sign that maybe I need something to manage that for me. And the other big thing is too, do I need to be careful about the order in which I'm executing various bits? Like they might interfere with each other, or maybe I can't even do that last bit without remembering to do the first three. So I think if you think about those three aspects, if you've answered yes to any of these questions, it's probably worth considering a pipeline. But, you might have really good strategies for the types of work that you do in scripting that you've developed over time that work really well for you, and that's totally fine. I do think, though, you can set yourself up for success without reaching for a pipeline immediately. So the first thing is to write functions. I know I've made a case for this already, but you will make your life easier if you write functions for your tasks. Another thing that I would recommend is to adopt a file structure for your projects that's compatible with targets pipelines and also with R packages, because sometimes you want a pipeline, sometimes you want a package. I find myself in this situation often. And it's really simple. All it means is you just put your functions in the R folder. Other people have opinions too about like, oh, you should, have one file per function. You should have a utilities file for the little function, etc. There are lots of schools of thought on this. I'm not even gonna throw my hat in there. I'm just gonna say at least put your functions in an R folder. And then you're good to go. If you want to turn it into a pipeline from a sequence of scripts, it's not hard. You don't have to go through your scripts and pull out all the function definitions, etc. Just work like this already. It'll work for your scripts as well. And I really think it's not that hard to just document your functions as you go, because sometimes they will turn into packages, or even when they're pipelines, if you're working with others, it's good to just have that layer of documentation, just a little bit of Roxygen commenting at the top of your function. If you're not familiar with that, you can take a look at the link, but just kind of doing a little bit as you go really helps, I think. And there are other reproducibility tools that you might want to consider. So there's renv, which is a way to manage a project-specific package library. So at the top of your scripts, you're pulling in a bunch of packages. If I send this off to my colleague, will they have the same versions of those packages or not? Maybe things won't work. Or what I get into trouble with is, hey, I have that code from 2 years ago. Will it still work with my current computer? I don't know. So renv is meant to try to address that issue. And then there's another really nice little package that I like to plug called config, which is especially if you're in that situation where you are developing on one machine and deploying on a server or another machine, and you're moving between machines, you can maintain kind of a record of, oh, here are the variables that I use when I run it on my computer, and here are the variables I use when I run it on the server. And you don't really have to touch those things. You can just seamlessly move across contexts for running your code and not worry about changing variables back and forth. Like I may only have 2 cores on this computer, but I have 32 on the server. I don't have to keep changing that variable as I bounce back and forth between the two machines. Okay, so all that said, I'm sorry I'm a little bit over time. Thank you so much for listening. The slides are there, tons and tons of links. If you'd like to reach me, I will pop my email in the chat, and I apologize for going a bit over. I don't know if I'm happy to take questions if there is time.
Totally fine. I've got one question in the chat, and I know you said you weren't going to throw your hat in the ring, but the people want to know, do you have advice on how to organize your functions? Do you source a big functions.r file or one per file?
Okay. I don't do that because I find it hard to I find it overwhelming to have one big file. I think it's fine if you like that. Maybe your setup, your development environment is more sophisticated than mine, but I prefer to have one file per major function. So like let's say I have like plot forecast. And in there I might have some helper functions too that are called in the body of that main function, but they're defined underneath. So I might have like a function to make kind of the basic panel or something that I'm going to reuse later somewhere else. I might put that underneath, or I might put that in utilities, plot utilities file or something. So I'm not super strict, but I do think one monolithic, I have a pipeline that has a monolithic functions file and I hate it. and I just don't want to touch it because it's an old project. But I don't think I'd ever do that again because it's so hard to find what I need to find quickly for me.
Makes sense. And then I was curious, do you have any personal projects you use targets for? I know you mentioned your website or your CV, and I was wondering if you brought that in.
Yes, I do actually. So this is a bit of a funny story, but my partner and I used to use Splitwise to share expenses. And we got to the point where we were using it so much that we couldn't deal with the daily transaction limit, like input limit. I think it's like 4 a day. And we would get behind and we'd put a bunch of stuff in and then, we're trying to consolidate things and like we get stuck on like we put 4 things in and now we have to wait till tomorrow. And anyway, and we didn't want to pay for Splitwise Pro. That's the key thing. So I actually made my own little expense tracker, and I use a pipeline to do it to basically pull in data from Google Forms. So we like put in expenses on Google Forms, and then my pipeline will take a look at the latest transactions, archive the ones from whatever month I'm looking at into like a separate sheet, crunch the numbers, figure out who's whom, make a report, like that kind of thing. And honestly, it's made our lives a lot better. It took a little bit of time. So far, no major bugs have been discovered where like, I don't know, I might be scamming him or he's scamming me. I don't know, but it has made life a little bit easier.
That is a really cute project. You're going to have to make that public with some anonymous data.
Yeah, I've thought about it actually before because I've told people about it, but I'm like, I don't want you to see what I spend money on.
Yeah.
So yeah.
All right. Well, we can go ahead and stop the recording.